Okay, so this is our project, which is about the relationship between COVID-19 and the economy in California. The background information and the prior work told us that the pandemic usually has a negative influence on economy, and our hypothesis is similar too. So we choose three important parameters to reflect the economy situation in California, which are unemployment rate, goods producing, and average housing listing price. Then we can use these three parameters combined with COVID-19 to find the answer we want to know. And all the data we used in the project are public and safe to use. So there are no ethical problems to worry about.
All right, so then we come to data cleaning. We first try to clean COVID data. The raw data is from Johns Hopkins, which update US COVID data every day separately. However, we need to know the infections in California by month. Therefore, we combine all the data sets into a large one and remove empty cells. Then we find that the confirmed cases, infection rates, and deaths are counted accumulatively. So we select them of California on the first days of each month, and then subtract consecutively to get the data of the last month. After handling the COVID data, we load datasets of California listing price, unemployment rates, and productions of goods. They are pretty clean, so we only rename the columns. Finally, we merge all COVID and econ data into one dataset called DF. It has a span from the beginning of the pandemic to the end of last year. Meanwhile, because we also want to study the trend and interrelationships within economic indicators in a wider time span, we merged a dataset called DF Econ. It contains data of listing, unemployment, and goods producing in the past 5 years.
After cleaning the data, we have conducted EDA from easy to complex, from single to multi. First, we compared the single variables. All of the variables have appeared to have a severe differences during the COVID-19 period. Secondly, after extracting important variables, we have an R value of 0.99 means a strong positive correlation. Therefore, we will remove incident rate in future analysis to avoid multi-collinearity. Third, we have single linear regression prediction. Single linear regression shows a positive relationship between COVID and the average listing price. It also appears the weak negative correlation with unemployment rate and the weak positive correlation with good producing. Fourth, which is finally, we have linear regression relationship between average listing price and death. We can see from this result that R squared is about the same of the multivariable regression above, which asserts our hypothesis that most of its significance comes from one of the multivariables. The p-value for death here is 0.003, which means we are almost certain that these 40% of the changes in average listing price is due to the change in death from that COVID-19. Finally, we have multivariable regression, both unemployment rate versus confirmed plus death, and also goods producing versus confirmed plus death. We can see from the result that R squared is 0.024 and 0.016, and p-value for both independent variables are too large to be significant, which means there is hardly any regressive relationship between unemployment rate and COVID-19 confirmed case plus death, and also hardly any regressive relationship between goods producing and COVID-19 confirmed cases and death.
So as we have shown in the EDA, all three economic status went through a huge decline at the beginning of the pandemic, even though there were not as many infections and deaths. However, as the pandemic developed, there were more and more infections and deaths. Yet the economic downfall started to slow down, even started to recovering at some point. In conclusion, there is no enough evidence to show that a strong relationship between the pandemic and the economic status.